Okay, so here's the plan for today. We're gonna go over the skills that are on the chapter test. I'm not going to go over the problems, but I'm going to go over the skills. All right, in order to be able to answer this particular problem, this is what you're being tested on, being able to do blank. Okay, we're going to go over that, and then I have a PowerPoint that's going to summarize some of the skills from the first 5 chapters. Right, and again, these are things that you should be able to do. And so, as you're taking notes on this, when we get to the PowerPoint, as you're taking notes, if you understand exactly what I'm saying, then obviously, you know that you have that down. If not, it'll give you a chance to take some notes and ask some questions about what that means. All right, and so the things that we're going to do on the PowerPoint are skills that you're supposed to take from Algebra II, from the first 5 sections, and be able to say, I can do this. Okay, now, you're not quite ready for that, but you're headed toward SAT math prep, right? And in the SAT math prep, there are certain skills that if you know how to do that skill, then you're ready with any problem that they give that relates to it. You'll be able to apply your knowledge to that problem and come up with the right answer. All right, so that's one of the things that I'm trying to do with you, is to get you prepared and say, all right, you can't forget this. Okay, so that's how so today we're going to work on 2 things. Now, so if you would, let's open to the test for chapter 5 on page 223. Okay, open to the test on 223. And I need to get a blank paper here. Okay? Alright, so now this is for notes. The first test questions says write the general equation. Okay, there are 2 types of presentations for quadratic. One is called the general form. And what's the other called? Do you know? Starts with a V.
Vertex.
Vertex form. Okay. The general form has the letters that you need to do the quadratic equation. Okay, now that should tell you automatically what the general form is. Okay, see that? So the general form, again, I'll say it again, the general form is the form from which you use the quadratic equation. And if you remember, it has to equal what?
0.
Equal 0. All right, one of the test problems that is always given for quadratic equations, because you can use the calculator, what they do is they put numbers on this side of the equation and people forget. And they just use the A, B, and C without moving everything over and getting a 0 on the right side. Okay, so number 1, remember that as far as testing is concerned. Don't do your best math work using the quadratic formula and not have changed it to equal 0. Okay, so now you know what goes there, all right? The vertex form starts with an A. Most of the time, that's 1. And so then you're going to have x minus h squared plus k. And hk becomes the vertex. The vertex is hk. All right, so let me give you an example. If I say 4x minus 2 minus 3 equals f of x, then what's the vertex?
2, 3.
2, negative 3. It is the opposite of this, and it's the same number that's here. Okay, so the vertex is at 2, -3, which is down here. Okay, now, if it were a parent graph, this number would be 1. And so from here, you would go over 1, up 1, back 1, up 1, because that's 1 squared, over 2, up how many?
4.
Over 2, up 4, because 2 squared is 4, right? So we would have and that graph would look like this. But this is not 1. So we would go over 1, up 1 times 4. And this, the graph that we have here would be super skinny inside that. Had this been a fraction, we'd gone over 1, up 1 times a half, if that was a half, and then it would fatten this thing out. Right? So the A is called a shrink, or a compressed shrink, or a stretch, right? And it changes if it's not 1, right? And then that value is the vertex. Once you have the vertex, you should be able to plot a parent graph. Everybody understand what a parent graph is? A parent graph is y equals x squared in this case. So what happens when x is 2? Y is 2 squared. That's why it's 4. Okay? All right, now so that's the first problem. And hopefully that's a slam dunk now. All right, now second problem says, for that equation, transform to the vertex form. Okay? Now, I just gave you what the vertex form looks like. Right? Okay, now, what's tricky about this problem? Look at the quadratic equation in T2. What did they give you?
A isn't 1.
A is not 1. That's what I was wanting somebody to say. A is not 1. So the first thing you have to do is to factor that out. Now let's say that I had this. That's a similar problem, right? Okay, in order to be able to get the vertex form, I need x, in this case, minus something squared here. In order to get that, I've got to take the 4 out. So if I factor the 4 out of here, the 4 goes there. Now, what happens when I factor a 4 out of here? What's left? 4 times what? 6. So this is minus 6. Right? Except that, what did I not do? I didn't take half of it. Remember? So, this would have been x squared minus 6x, and when I take half of it, that becomes a 3. So do you notice that there were 2 steps? All right, and I just demonstrated the first major problem that people have, and that is they take the 4 out, but forget they had to take half of what was left, not just put it down here. Okay, now, what's the number in here, the third part of the trinomial when I square this? I'm going to have x squared minus 6x plus how much?
9.
Plus 9. So if I added an extra 9, then I have to subtract the 9, and then these two will make negative 6. Now to check it, I know that this is a positive 9. What is 9 minus 6? That's the 3 I was given. So I know that I have not changed the problem. And now that's the vertex form. So what's the vertex of this problem?
3, negative 6.
Positive 3, negative 6. So 3, negative 6 is the vertex. All right, now that's what you're supposed to do with the problem that you've got in T2. All right, make sense? Whoa, almost pulled it off. Okay. All right, now T3. x-intercepts mean? Very simple.
The x-intercepts.
Means the solutions. Solutions x-intercepts and zeros all mean the same thing. Okay, so what's this asking you to do? Problem T3.
Use the quadratic formula.
Use the quadratic formula to find the answers. Right? Answers for x. So all of these things mean the same. Why do they make them different? To confuse you. To confuse you. To see whether or not by using a different reference it makes you confused, or whether or not you can still understand because you understand the vocabulary. All they're asking me to do is solve the problem. Now, solving the problem is what? Quadratic formula. Okay? All right, now T4. I don't think I need to go over that. What does this mean? F of 3, what's it mean? I'm looking for an R word. Nobody give me an R word? RE word?
Relation?
R-E-P word?
Oh.
R-E-P-L?
Replace.
Replace. Replace the X with a 3.
Oh, okay.
Okay? Replace, that's all it means. Replace the X with a 3.
Gotcha.
Okay? Alright, so now, so that one sounds like some people have just learned something. Okay? Or at least learn how to very quickly demonstrate that you understand what to do. Right? It means replace the X with a 3.
Quick question.
Yes?
For B, though, I always forget what to do because it says f of x equals 5. Is that you?
Okay, f of x is the same as y. So what happens if y equals 5?
Well, so then
Okay,
once you
all right,
put
so
it into
let's say that normally I'm going to do it this way. I say ax squared plus bx plus c equals what?
5.
No, we find it for it's 0. Now here's something that you may not have understood. Where's y0?
Right in the middle.
Where's y0?
Right.
On the x-axis is where y is 0. Where are the x-intercepts located? On the x-axis. So if I set y to equal to 0, I'm finding the same points. Now, what did the problem say? It said that y was 15 in this case, right? So what do I have to do to solve the equation?
So would you add 15 to C? Or
I wouldn't
subtract?
add, because my maths is better, right?
Right, yeah.
Right, because in order to use the quadratic formula, you have to set this equal to 0. So you're just going to subtract 15 and then use your quadratic formula.
Okay, so that's
Okay, that's all right now.
Yeah, okay.
But understanding that f of x equals a number means that this number that we set to 0 was actually started as something else. Okay, now once you understand that problem's easy.
Right,
Until you understand it, that problem will mess you up every time.
See, that's what I thought it was, but for some reason I always forget.
Okay, all right, that's a good question, all right? So the reason that we see we're like it says x is 5 or y is 5, right? That means that I would want the y where that line is right there, right? But I don't have any skill, at least not a really ready available skill to find a value where y equals 5. But I do have a way to find it where y equals 0. So all I do is I change this back to y equals 0 and then use the quadratic formula.
Gotcha.
Okay. That make sense? Okay, so that problem's really easy once you understand it. All right, now, suppose that, and it gives another quadratic formula, it says use the discriminant. All right, what are the things about the discriminant that you're supposed to know? There are four different possibilities. If you use the discriminant, right, and you should know what it is, right, you should know what that is, right? If you use the discriminant, you have four possibilities. One, and I'm going to go the easy one first. It's negative. What does that mean?
Imaginary number.
It means how many?
Oh.
You have two imaginary solutions. Maybe I spelled imaginary wrong because I just had a brain freeze. All right, you have two imaginary solutions. Right? What happens when it's 0? All right, when you have 0, you're going to have negative b plus 0, negative b minus 0. So you're going to have one dual, D-U-A-L, solution. Now, sometimes these are called roots. All right? And now, the third and fourth have to do with positive. If it is a perfect square, then I'm going to have two real, not imaginary, real rational, because if the square root is a perfect square, I'm going to have a whole number on top. Right? And a whole number divided by 2a is the definition of rational. Okay? Now, what happens if the square root's not perfect? Then I have two real irrational answers. And these are solutions. All right, now, one thing the book does not ask, if you have an imaginary, if you have two imaginary, what would the graph look like?
It would,
okay. The graph is going to either be up here or down here. It's never going to cross the x-axis.
Right.
Okay. If it's a dual root, it's going to be touching, either like this or like that. It'll be, the vertex will be touching the x-axis if you have this solution.
Right.
And then if it's real, all right, if it's real, it's going to cross it. Okay? And so if it's real, it's either going to be like this or it's going to be like that, so that it's crossing. Okay? Now, that information that we just went over is not stressed in the book, but is often testable for overall knowledge of Algebra II. Okay? So, basically, if you understand these four parts, and you can relate it to this and what the graph looks like, then you've got that information down. Okay? Everybody done with that part?
Yes.
You ready?
Yeah.
Okay.
Actually,
All right. All right, I think we can get through one, maybe two more before I go to clean the board again. All right, given that the vertex of a parabola and that the intercept, sketch it. Okay, this one is one that I have found to be very interesting. So I'm going to bring up a form for us to look at this. Oh. alphabetical. Oh, we have, oh, 1700. Okay. Now, okay, so here's what we're going to consider. All right, we're going to graph an equation. Okay? All right, so I'm going to give you, first of all, the vertex form. All right, so let's say that I give you x squared minus 6x and then plus 4. Okay, equals 0. All right, now, what's going to happen, there's two ways to get it, but if I were to create the vertex form, I have to do what? Take half of this, which would be x minus 3. Right? Everybody agree with that? If I was creating completing the square. Now, I also know that negative b over 2a is the x value of the vertex. So it will be positive 6 over 2. How much is positive 6 over 2? Plus 3. Right? So that means this. That my axis of symmetry that goes through the vertex is that blue line. Now, where is the vertex? All right? If you remember, after you get this, then what I want is, whoa, why is that not working? That one's dead. This is the one I'm using. I want f of 3. That's the reason you had to know that. All right? So because the vertex has a 3 here, I want f of 3. How much is that? It is 9 subtract 18, which is negative 9, plus 4 is negative 5. So that makes the vertex 3, negative 5. Where's that located? It's located right down here. Now, what happens when x is 0? 0, 0, 4. So the y-intercept is 4. What does that tell me? If this is the line of symmetry, then this distance and this distance is exactly the same. So if this is at 0, 4, right, and this is at 3, if I go 3 more, this will be at 6, 4. And now I can draw my parabola. So that's all it's asking. What it's asking you to understand is that given the axis of symmetry, no matter where this is, you can find a parallel point that's symmetrical to this by going, whatever this distance is, go the same distance and put the point without going up or down on the y-value. So if I find that this is 6. So let's go back to this equation here. All right, that 4 becomes important, doesn't it? Now, don't we also have that when we have a linear equation? Yes. Right, 1/2 x plus 3. The 3 is where we start graphing, isn't it? Well, this same position helps us to be able to identify a symmetrical point because the distance from the vertex or the intercept to the axis of symmetry is the same distance to the other side in the symmetrical relationship. And so you can find that point. If I were doing a test I would ask for this point. Why? Because that forces you to tell me what it is. Right? Right now, all you have to do is graph it. And so what you're going to do is you're going to take this point and then did the last thing I did, and then just try to draw the parabola between the vertex and those 2 points. All right, does that make sense?
Yes.
All right, question on that. Now that problem is not stressed in the text that much. Right, but it's a testable question. Okay? All right, now, see if I can do this without getting hurt. All right. Now, what is the, all right, that was T6, right?
Yes, it is.
Okay, so the next one says solve if the domain of X is a complex number. Now, what does complex number mean? I'm looking for an I word.
Imaginary.
It has an imaginary part, right? So it'll be some number plus some number I. Okay, what does that mean? That means that instead of having no solution, because it was not real, now you have to find the solution with an I. Okay, so what's going to happen when you do the square root of the quadratic formula? What are you going to expect to see when you do the square, when you do the determinant? You're going to look for a negative, and in order to be able to get the value, you're going to have to take the negative part, make it an I, and then take the square root of what's left. Okay, so you're going to have some number like 5 plus some number I, and then 5 minus some number I. May not be 5, whatever the book is giving you for B. Does it make sense? So in this place, it looks like they're asking you for 2 imaginary solutions. Okay? Does that make sense? Mm-hmm. All right. Now, all right. Solve if the domain, all right, that's T. Now, T8. Do you notice that, that the area, okay, it says a small motel is built as shown, okay, with 2 long walls and 6 short walls, X feet in length. The total length of the walls is to be 300. Now, what does total length mean? It means X plus X plus X plus X plus Y equals 300. That's how you start that one. All right, and then it's asking you to just answer those questions. Okay? All right, so that test should be relatively straightforward now. All right, questions?
Is this test homework?
I'm sorry?
Is the test homework this week?
Yes, yes. You're assigned the test this week to turn in next Tuesday. Okay, Wednesday for you people.
Which test?
The one we just went over.
This one?
Yeah.
Oh.
Yes. All right. All right. Test. You have test 5, and then you're going to have the cumulative also, and then you're going to have a test in here next week. Okay. Now, so that's the first part. Let's see if we can move forward. And I'm going to try to do this. Oh, I got to clean the board first. I don't know how much I got left. Okay. Let's see if we can get this place to be real smelly again here. All right. It's not real close in the middle. I'm out of cleaner. What they gave me was just rubbing alcohol. And the problem with rubbing alcohol is that it evaporates faster than you can get it wiped off. Okay, now I'm going to try this. I've not done this before, so okay. All right, you got to read that.
Do I really?
No, that's really funny.
I'm sorry.
Do
appropriate for what we're doing.
Yeah, right? Yeah.
Okay, so, all right, so we're going to go through here. There's three forms. Three forms of quadratic, or no, this is linear equation, I'm sorry. Linear equation, because our chapters, chapter 1 and 2, start out with linear equation. Standard form of a linear equation, right? Slope-intercept form and point-slope form. This is the one the book gives for point-slope. But, uh-oh, wait a minute, I made a mistake. You didn't even get there yet, so you're okay. Oops. What we're going to do is we're going to add k to both sides. This is the one you normally have. Because we have y equals, this is normally how we do that, so that k ends up out there. Okay? Now, the paragraph for this, for a linear equation is y equals x. So when x is 1, y is 1. When x is 4, y is 4. When x is -3, y is -3. Now, how does this graph move up or down? How does the graph move up or down? You're going to add some value b, and you will move this graph up and down. All right? How do we change the slant of the line? We change the slope to be either positive or negative, and either a fraction that's less than 1 or some value that's greater than 1, and we will change this fraction. This has a slope of 1 because it says y equals 1x. Okay? All right, now, that should not be new information. There may be parts of that you hadn't figured out, but that's how they all relate. All right?
Is it missing a square? Wait, slope?
No. Although the quadratic looks very similar.
Okay, the quadratic equation.
See, this is the point slope. So, and again, in the quadratic equation, I would have this value and this value, and I would have a square there.
Okay.
Yes.
Yeah,
So they're very similar.
Oh,
That's the reason that I put the slope point in this form.
Got it.
Okay.
Got it.
All right? Okay. Now, linear intercepts. What is an intercept? It's a place where it crosses an axis. Okay, now this is important. The y-intercept is where x is 0. Right? Now, when x is 0, y is going to be c divided by b.
Yep, right.
See that? When x is 0, this is no longer there, right? Now, what is y? C divided by b. Okay? Now, the x-intercept is the same thing, similar thing. When y is 0, x is going to be c divided by a. So, when y is 0, the value of x is c divided by a, and when x is 0, the y value will be c divided by b. Now, that's not taught, but that's important for linear equations. Okay, see that? Now, if you know the slope and you know the y-intercept, you can write y equals mx plus b pretty fast, and then be able to graph it. All right? Ready to move? Almost? Okay. All right, good. All right, here we go. Oops, what happened? You hit the wrong spot. What did I do? Oh, I know. I pressed the wrong one over there. Okay. All right, now, transforming linear equations. This is one of the skills from the first problem. You should already know how to do this. All right, in order to be able to transform this to y equals, I have to subtract this term, then divide by this term.
Yeah.
Now, if you remember, the intercept is still going to be c divided by b, right? But in this case, the slope is going to be the opposite of a divided by b. Now, how is that related to quadratics? Remember that the x was negative b over 2a. Right, so there's a relationship there. Right now, so this right here is something that you learn. I don't think you need this for what you're doing, other than you need to understand that you can find slope from this without ever having to change it. Right? If you can do the math in your head, negative a divided by b is the slope of that line. Okay? And then once you're in that, if you have this equation, to change it back, you multiply everything by 2, and so I have a 2y and a 12, and then because this is negative 3, the negative 3 is going to come to this side. My standard form will be 3x plus 2y equals 12. Now, the intercept is 12 divided by 2, which is 6. 12 divided by 2, and the slope is negative 3 divided by 2. Negative 3 divided by 2. Now, I do not necessarily like that it's not covered in Algebra 2, but that skill is drilled in Algebra 1.
Yeah.
And you're supposed to bring this skill with you. Right? But I have found that some people sort of slid by that skill and didn't take it. Right? And so this became like new material.
Right.
Okay? Alright, really all we should have been doing is just learning this. This is the Algebra 2 skill, to be able to take the standard form and come up with the slope and the intercept without actually doing the math. This is the Algebra 2 skill. But in order to do that, you've got to have brought this from Algebra 1. Okay? Alright, ready to move? Okay? Alright, now, finding the linear equation. Given 2 points, and again, this you should know. Given 2 points, find the equation. First thing you have to do is get the slope. Alright, y number's on top. 8 subtract 5 is 3. 4 subtract 2 is 3 over 2 is the slope. And, right, if I know that, then I have the m. To find the b, I have to just find the x and the y. Well, I got 2 of them. I just use whatever pair. And when I get that done, I find that b is equal to 2. And so now I have the m, and I have the b, and so I can say y equals 3 over 2x plus 2, which is the slope of the line. What happens if I have to change that? Multiply everything by 2, that becomes a 4, and then this is already positive, so the 2x comes over as negative, and the 4 goes over as negative. And I get 3x minus 2 equals negative 4 as the standard form for these 2 points. Again, that was covered, I think, in Chapter 2, and it is a skill that you should be able to do. Now, I will send you this PowerPoint, okay, which will help. But taking notes helps you remember, so don't stop doing that. Yes?
On tests, usually when it's asking for an equation, does it want you to give standard form or point slope? Or slope intercept?
A good test will tell you.
Specify? Okay.
A good test will tell you.
And if it doesn't, what form do you usually give?
Technically, for Algebra 2, to answer that question, technically in Algebra 2, you're supposed to always answer the standard form. Right, but if the test doesn't tell you, then you could stop here, because that is an equation.
Right.
Okay.
Right? But normally, a proper test for Algebra 2 is going to say, what is the standard form equation for these 2 points? Okay? Now, this skill, this same slide can be used in Algebra 1, except I just don't do the last step. So, okay? All right, now, so graphing. Again, this is not new. If I give you the point slope, and I ask you to graph it, you start with negative 4, 1, plot it, negative 4, 1, and then I want a slope of 2. That's up 2 over 1, up 2 over 1, draw the line. And again, that should not be news. Okay. All right, now domain and range. This is something that you should know. All right, domain refers to the x values of the x-coordinate, range refers to the values of the y-coordinate. The function coordinates 1, 2, 3, 4, and 5, 19 has a domain. Whoa, that's supposed to be a 0. All right, why is this supposed to be a 10 and not a 19?
Because the range is 2.
What's the relationship?
Oh,
What's the relationship between x and y?
they're all multiplied.
You take x and do what with it to get y?
Double.
Look at double it, which is, give me a math term for double.
Square.
No, not square.
Square,
Multiply by
2.
2, right? And so 2x equals y is the equation of this particular function. Because every x is multiplied by 2 to get the y. Okay? Now, so the domain is just gotten by taking the x values, the first numbers, the range by the second numbers. Yes, sir?
Where did the 5 come from?
I just created it.
Oh, but the 10 came from.
Oh, wait a minute. Oh, that's... Wait a minute. Here, 1, 3, and 5 are what values? They are the x values.
Yeah.
So the domain is 1, 3, and 5. The range is the y values. So it is 2, 6, and 10.
Oh.
All right, see, in order to be able to determine whether or not you understand the difference between domain and range, we have two choices. I can give you a drawing and ask you to give me the domain and range of the drawing, or I can give you a set of points and ask you for the domain and the range. Right? The second thing you do with a set of points is ask you whether or not it's a function. All right? It's a function if the x's do not repeat. So every x has only one y to go to. If the x has two y's to go to, it's not a function. Which is the next point of this. All right, so did that answer your question? All right, so, and again, why did I choose those? I chose these because there was a functional relationship, and that is that y is equal to 2 times x. All right, and if I gave you something much more difficult than that, you'd been really hard to figure out. Okay, now, remember I just said that the two ways to do a function, one is to give you a set of points, the other is to give you a graph. Now, tell me about the domain of this graph. The domain has a high value of, how about 1? Domain is the x values.
Right.
So the domain has a high value of 1, and you see the solid point? So it equals or is less than 1. And what about here? A low value of -3, but it is just greater than, not equal, because that circle is open. Now, it touches -4, so it could be greater than or equal, and it touches 0, so it could be less than or equal. And so this becomes the domain of this function, and this is the range of the function. Just figuring out what's the max, what are the limits of the x's, what are the limits of the y's. Now, that's an Algebra II test skill. Okay, and we had a whole chapter on that, and it was ugly at the time. Right?
I like this chapter.
Okay?
Oh.
Listen, anytime you understand it, it's easy.
Amen.
And every time you don't understand it, it's hard.
Very true. True that.
Yeah.
It's always hard.
And it's going to remain hard until you learn something about it. Then it gets easier, and eventually you understand it, and then it's really easy.
Yeah.
All right, that process doesn't change even when you're old. Okay? All right. Is that it? Okay, let's move on. Okay, absolute value equations. Okay. I happen to like dual equations for algebra. I do not think, personally, I do not think that a high school student should do two separate equations because you're smarter than that.
Yeah, it's easy.
You're smarter than that. All right, so if you understand that the absolute value could have been negative or positive, and it's going to end up being positive, you actually have this situation. You copy that sign, put the negative here, and then you're going to solve it using algebra. And hopefully, I think I've got this. All right, so the first thing you're going to do is subtract 9. So you subtract 9 from all those sides. Right? And that's going to give you... Now, should you have to do this, you can do this math, right? Don't worry about doing the math. Just get those two things I started with down. All right? And when you subtract the 9, you end up with this. All right, what's the next thing you have to do? You divide by 2. All right, when you divide by 2, you end up with this. Now, my question, how do you graph that? What does this say? X is greater than 7. That means you're here going out that way. Read this backwards. X is smaller than negative 11. That's over here going this way. Had these things been reversed, you would have come together in the center. But you just read it this way. If this is headed out, then you know the other one's got to be headed in the negative direction.
Right.
That's another thing, that's a generalization that works for the absolute values. Okay? All right, questions on that? All right, if you don't do it this way, that's okay. It's just, this makes you cool. This makes you cool.
That makes you cool.
All right? Okay? All right, now, systems of equations, elimination method. What does eliminate mean? What's eliminate mean?
Get rid of
Get rid of it. Get rid of it. Which is the easiest one to get rid of? If I get rid of the y's, all I have to do is transform this 2 into a negative 4.
Right.
Right? So it would be easier to get rid of the y's. If I wanted to get rid of the x's, I'd have to multiply this top one by 4 and then the bottom one by negative 3, and then I'd have 12 minus 12 is 0. Right? But I like this faster. Okay? Now, again, elimination method is something that you should know how to do. Right? But remembering that if the directions say by the elimination method, you have to prove to me you can do it. All right? So in this case, I think I've got that. I'm going to transform this by multiplying it. And now these two things are going to get added together. What's going to happen here? 0. So this is Adam. 11x is Adam.
22. Which equals
11x is 22. All right, and now what? X is
2.
X is 2.
That was awesome.
All right. So now I have this equation, right? And if x is 2,
6 plus 4.
then this becomes, well, here it is. Now, if x is 2, then, oh, what happened here?
What's that?
All right, there it is. Then I replace the x with the 2 and have 6 plus 4y equals,
4.
subtract the 6, and I get 4y equals,
Y equals negative 1.
no, I said 4y equals negative 4, and so y is negative 1. Now, if I was doing this, I would have another slide. It says if I put a 2 here and a negative 1, I have 8 plus 2 is 10, and it works. If you're going to find the answer with the first one, you put them both in the second one, and it should also be true. If you made a math error, then the second one wouldn't work out. Because somewhere in here I made a mistake. Like, I dropped the negative and had a positive 1. If you put it in here, 8 minus 2 is not 10. So I know that positive 1's the wrong answer. Okay? All right, that should be now. All right, Kramer's rule. Again, you guys really picked up Kramer's rule, and I'm glad you did.
I can do this.
I'm glad you did. Okay? Alright, so in Kramer's rule, boy, this was hard to do. But in Kramer's rule, the denominator is going to be the matrices of 3, 4, and 1. Whoa. I changed the number. It's supposed to be 4. Pardon me. You can tell I was doing this late last night. Okay. No problem. Fortunately, just okay. Now when we do it, now we have 3, 4, and 4, -2 as the denominator of both fractions. Then I take these answers, replace them with the x. That gives me this, right? And the same thing would be true with the y. I replace these answers here with the y and get 3, 4, 2, 10. And then you use the, we're going to go diagonal minus diagonal.
Right.
Diagonal minus diagonal. Mathematically, it's going to be -4 minus 40, and it's going to be -6 minus 16.
Gotcha.
Right? And the same thing would be true for that one. Just different numbers. Then this becomes -44 over -22, which is dosos. Right? And this becomes 32 over -32, which becomes -1. Okay? And so that became the solution. All right. Third thing, or fifth thing, wherever we are. All right. Systems of inequalities. All right. Graph carefully each inequality and find where they all interconnect. Okay. Are we that late? Oh. Okay. All right. So this one says y equals. So how do you plot this? You start with the 3, right? And then you're going down 3 over 1, down 3 over 1, and drawing the gold line. Then this says y is greater than or equal to -4. Well, that's this line, and it's above it. And this says y is less than x. Y is less than 1x. Wait a second, that's not what that line is. It's 1x plus 3. Okay. No problem. Nobody will ever know. Except if they see the tape. Okay. So y equals 1x plus 3 starts at 3 over 1 up 1 over 1 up 1. Okay. And then because this is below, and this is below, and this is above, it becomes that area in there. All right, that's a test question. All right, most of the time where I've seen this is that you're given 3 or more drawings. You have to find out which one works. In order to do that, you have to interpret these equations to be true, as well as what part has been shaded in.
Right.
So be careful on that. Okay, now quadratics. Now we're moving up into the latter couple of chapters.
Right.
All right, standard form, vertex form. Okay, I've already been over that. Now, the parent graph. The parent graph, when x is 0, y is 0. When x is 1, y is 1 squared, so it's over 1 up 1. When x is 2, y will be 4 over 2 up 4, and then over 3 up 9. The same thing with negative. -1 times -1 is positive. -2 times -2 is positive 4. So this is the parent graph. Okay? If the value here is 1, after you find the vertex, you go over 1 up 1, over 2 up 4, draw your, and you're done.
Right.
If the A is a 1.
Yeah.
Okay, now, that's not stressed, but I find that is so simple. After you find the vertex, it's a parabola, which means what? It's symmetrical. And once you find the value here, this is a change of 1 times whatever that number A is. Right? So we're going to square 1 and then multiply it by this. we're going to go over 2. So we're going to square the 2, and then we're going to multiply it by whatever a is. To me, this is easier than what most students consider it.
Yeah.
Okay? Right? So, now, completing the square. Again, this is a skill. I was doing a tutoring in Algebra 1. Chapter 6 in Algebra 1 is completing the square. You cannot do vertex form unless you can complete the square. You should have been told that in Algebra 1. So that you didn't forget what to do. Okay, so the harder one is when this is not just x squared. Because the first thing you have to do is to get 1x squared. To do that, I'm going to factor a 2 out of this term and a 2 out of that. And get x squared plus 6x. Then I take half.
Right.
So half of this will give me 3x squared. But how many terms did I have inside the parentheses here? 2. All right, this has 3 terms. So it has an x squared, a 6x, and it also has a 3 squared 9. Right? So I've added 9 times 2. I've added 18. If I don't subtract 18, I've changed the problem. That's the only thing you've got to understand when it's that value. Now, when I look at it, I started off. Did I change the problem on this one too? Yeah, I did. Yeah, I changed this. I changed this to 14 because I wanted it to be. I wanted this number to be something reasonable.
Right.
All right, so I got to go back and change that. First period class on anything that you do new always gets this. So, all right, that's supposed to be a 14. So when you're done, if you notice that this was a 9 in here, right? All right, the 9 times 2 is 18. What is 18 subtract 4? It's 14. So you can verify that you got the right number here. That's why I knew the 9 was wrong. I was about to show you that. So this is 3 squared, that's 9 times 2. 18 subtract 4 is the 14 that you would have right there. Okay? Now, so if I have this, how do I plot it? I'm opposite, so it's -3, -4, which is right here. And then I go over 1, up 1 times 2. That's over 1 up 2. And then I go over 2, up 2 squared, 4 times 2, that's up 8. Over 2, up 8. And then if it was 3, it would be 9 times 2, 18, which is off the scale. Okay? And that's what I've got here. All right?
Yep.
Oh. All right, I actually had some cool stuff there. All right, okay. Quadratic formula. All right, quadratic formula you've got to remember. All right, and remember that depending on your calculator, you have to put parentheses around the numerator before you put it in the calculator. A lot of times I like to write that and then put the parentheses here. Some of the newer calculators, I was looking at Xavier's calculator, when he presses for square root, he has this, there's no parenthesis here. It stays under, which I thought was cool. So when he's done with the square root, he has to press the arrow key to get outside. On the older graphing calculators, you got to put the parenthesis on both sides. It gives you one here, and you have to put a second one there. You need to know how your calculator works. Calculator is a dumb instrument. It has no idea how to do that stuff.
Right.
So if you don't tell it to do the right thing, it's going to do the wrong thing. Okay? All right, now determinant. B squared minus 4c, we already covered that. All right, what are the 4 different ways? You can have negative, which means you have 2 imaginary. Okay, if it's 0, you have 1 dual root. If it's positive perfect, you have 2 real rational. And if it's positive non-perfect, you have 2 irrational. And you might say real irrational. Okay? All right, and there they are. Okay, so you've learned this. Some of you maybe you've learned it today. All right, that's important to know. Okay, so the vertex is at negative b over 2a. So what would be the vertex of this? Negative b, which is negative 12 over 2a. 4. What's negative 12 over 4? Negative 3. And then I have to put the negative 3 back in here to find out what f of x is. Okay. So when I do that, I get all that junk, but I still end up with negative 3, 4. Okay. All right, now, the line of symmetry, this is important. The line of symmetry, once you get this, the line of symmetry is x equals negative 3. All right, that's right. All right, now look at this. Okay, the vertex. Ding. I should have had a little bell go over that, right? Okay, now, also, remember this?
Yes.
Yes.
All right, that means it's right there. How far apart is this? How far apart is that? 3. So what does it mean? That I have to go 3 units on the other side in order to be able to put the symmetrical point.
Right.
See how that works?
Yes.
All right, now that makes graphing it real easy.
Yes.
Isn't that cool?
Yes.
All right. All right, what time is it? 31. It's time to leave. Okay. All right. Now, if I'm here next week, then we will finish up. All right. You have a test assignment, right? You also have the chapter review assignment. Right? The chapter review and there's two things. There's 2 things in the test. Let's look at it real quick.
Wait, did you ever pass out the test?
All right. No, I'm talking about the book test. The book test.
Yeah.
Okay. All right. Let me get the page numbers out for you. All right. You have page 221, all right, which I think you're turning in. That's the review.
Yeah.
All right. Okay. Then on page 223, you have the chapter test. That's the first thing we went over today. Right? And then section 5.9, which is the extra credit cumulative review. Right, which starts on page 224 and goes for 3 pages. Okay? All right, so all that is due next week. Next week when you come in, you were supposed to have a sit-down test, but I believe that that's going to be changed to a take-home. Okay. So what will happen is there's a short, and I do mean short, shorter than the chapter test. There's a short cumulative test which my PowerPoint is helping you on. Okay. All right. So if you have questions, we can do that after, but otherwise, a good day. Thank you for your participation and your concentration.